Why is X11 forwarding so inefficient? Whenever I remotely launch large GUIs with X11 forwarding, even including the C switch, the experience is very unresponsive. My question is, what does, at the concept/protocol level, cause this? With my 25 Mbit connection, I can stream HD video to my computer absolutely without a problem. On the other hand, the unresponsiveness of remotely launched GUIs with X11 forwarding happens even over a 100 Mbit LAN, where the latency should be near zero. I understand that as opposed to video streaming, the latency will be at best doubled, as the input needs to be sent to the remote machine and only after that can the application respond. But internally, are there other factors which increase the latency even further? Secondly, the bandwidth. Why does it eat up so much of it? When it comes to picture and video formats, many methods are used to drastically reduce the size. In the case of BMP versus PNG, for example, a large black square image will take way less in PNG representation because information is not stored for every single pixel, but in a range-ish way as far as I understand. In the case of videos, a whole lot of information can be saved by sending the difference between frames rather than the whole frames. I know this is very simplified, but is X11 not using these methods? Does it behave in a bitmapish or a non-differential principle at some level? And if not, why does it take up so much bandwidth?
The X11 protocol was never meant to handle graphically, in terms of bitmaps/textures, intensive operations. Back in the day when X11 was first designed, computer graphics were a lot simpler than they are today. Basically, X11 doesn't send the screen to your computer, but it sends the display instructions so the X server on your local computer can recreate the screen on your local system. And this needs to be done on each change/refresh of the display. So your computer receives a stream of instructions like draw line in this color from coordinates x, y to 20, y, draw rectangle w pixels wide, h pixels high with upper left corner at x, y, etc. The local client isn't really aware what needs to be updated, and the remote system has very little information on what the client actually needs, so basically the server must send a lot of redundant information that the client may or may not need. This is very efficient if the display to be rendered consists of a limited number of simple graphical shapes and only a low refresh frequency, no animations and such, is needed. Which was the case back in the days when X11 was first developed. But modern GUIs have a lot of eye candy, and much of that needs to be sent from the remote system to your client in the form of bitmaps/textures/fonts, which take quite a lot of bandwidth. And all sorts of eye candy includes animated effects requiring frequent updates. And the displays keep getting bigger too, twice as wide/high is 4x the number of pixels. Of course, over time, enhancements to the X11 protocol were made to optimize this as much as possible, but the basic underlying design is, in essence, simply not well suited to the demands of the kind of GUIs people nowadays expect. Other protocols, like RDP and VNC, are more designed to let the remote system do all the hard work and let that system decide which updates to send to the client, as compressed bitmaps, as efficiently as possible. Often that turns out to be more efficient for modern GUIs. Neither method is perfect and can deal with every situation equally well. There is no such thing as a single display protocol that can do well under every conceivable use case. So in most cases you just try all protocols that are supported between your local client and the remote server and use the one that gives the best results. And in some cases there is no choice and you just have to make do with whatever is available. Most protocols do allow some performance tuning, but many of these settings are server-side only and not available to the average user. And configuring them properly is a bit of an arcane art. A lot of sysadmins won't be willing to mess with that. In most cases, the easiest way to improve performance, sometimes quite dramatically, is by switching to a more simple desktop environment with less eye candy and forego the use of background images.
There are primarily two reasons for X11 connections to be slow, both of which you touched on in your question: bandwidth and latency. To understand why X11 apps are slow over a network, let's discuss both of these. Bandwidth. X11, by default, doesn't do any compression on the network data that gets passed between the application and the display server. As you mentioned, you can use the C option on SSH to enable compression, and while this does help, it's not optimized for compressing graphical data. Compared to formats like H.264, which can obtain compression rates of 100 to 1, the C compression will be lucky to achieve 2 to 1 compression. A better solution is to use a graphics or video optimized codec for the X11 video, but we have to be careful not to make it too lossy, as desktops generally need to have sharper images than a movie so the user can still clearly read the text and make out fine details. Latency. X11 tends to have high latency because most operations require multiple round trips between the application and the display server. When run across a LAN where ping times measure less than a millisecond, these multiple round trips aren't noticeable, but across an internet connection they add up quickly. Solutions. A number of years ago, there were a couple projects built to address the bandwidth and latency issues inherent in the X11 protocol. LBX, Low Bandwidth X, and DXPC, Differential X Protocol Compressor. I don't think LBX ever got much traction, but DXPC became the underlying technology used for a product called NX. NX uses both lossy compression to reduce the bandwidth requirements and a differential algorithm and caching to reduce the number of back and forth information passing that creates the high latency. I've used NX quite often and find the performance to be almost as good as local applications. If you're feeling up to it, you might try it and see if it works for you. The downside is that it requires installing software on both ends of the connection, whereas X11 is generally already installed.
If you want to support the channel, please consider subscribing.